A capacitor is a device that stores electrical energy in an electric field. When a DC current and voltage is flowing through the capacitor, it collects this charge and stores it inside. This is the charging stage. When the circuit is opened by turning off the switch or disconnecting a wire, the capacitor starts to discharge. Capacitors behave differently in parallel and series circuits. The total capacitance in a parallel circuit is equal to all of the capacitances added together. 1 over the total capacitance in a series circuit is equal to 1 over the first capacitance plus 1 over the second capacitance plus 1 over the third capacitance. Here are some useful formulas. The time constant tau equals RC, which is the total resistance times the total capacitance. This is significant because it is the time that a capacitor takes to charge to 63% of its source voltage. After 5 time constants, that's usually when the capacitor is fully charged. The charging formula and discharging formula are written below. Here is an example. Given the circuit shown, calculate the total capacitance. Using the formula C total equals C1 plus C2, we get C1 as 100 microfarads and C2 as 220 microfarads. When you add them together, you get C total equals 320 microfarads. Given the same circuit, determine the time constant. Using the formula tau equals RC, we get tau equals 100 times 10 to the 3, because it's 100 kilo ohms, times 320 times 10 to the minus 6, because it's 320 microfarads. Given this, we get tau equals 32 seconds. Calculate the charging time. Charging time equals 5 tau. We calculated tau in a previous question as 32, so 5 times 32 is 160 seconds. Calculate the voltage across the capacitors after 25 seconds. Using the formula VC equals E times 1 minus E to the negative time over RC, and subbing in our values of 10 for the source voltage, 25 seconds for the time, and 32 seconds for RC as tau, which we calculated before. Type this into a calculator, we end up with VC equals 5.4 volts.